In this section we're going to work with proportions. Now recall that the ratio of A to B is A over B. A proportion is simply two equal ratios. When A over B is equal to C over D, we get what's called a proportion. Now the two outside numbers, that is this first number A and this last number D, those are called the extremes of the proportion, and the middle numbers, this B and this C, those are called the means of the proportion. So the outside numbers are the extremes and the inside numbers are the means. Now the property that we have of proportions that comes from this multiplication property of equality is this. The product of the means is always equal to the product of the extremes in any proportion. So if you multiply A times D, it's always the same as what you get when you multiply B times C. A times D is equal to B times C. Some people call that cross multiplication. I like to say the product of the means is equal to the product of the extremes, or you can say it the other way around. The product of the extremes is equal to the product of the means. This product right here and this product right here are always equal in any proportion. Now that's the property that allows us to solve proportions for one of the missing terms. Let's take a look. Problem number 1, we want to solve 2/5 is equal to 4 over x. So remember, the product of the means is equal to the product of the extremes. So 2 times x and 5 times 4 are going to be equal. So I'll use my means extremes property to write this as, and I'm just going to say this implies that 2x is equal to 4 times 5. So 2x is equal to 20. Now I want to solve this for x. I think you can see that x is equal to 10, but let me show the work where I divide both sides by 2. So those factors of 2 divide out, and I have x is equal to 20 divided by 2, which is 10. So a very simple process in solving a proportion like this that's missing one of its terms. Here I have x over here. It's just going to be the product of the extremes is equal to the product of the means. I chose to put the 2x over here first because I like to have x on the left side of the equation. Let's look at another one of these problems. 1/2 over y is equal to 1/3 over 12. Again, the product of the extremes is equal to the product of the means. So y times 1/3, which is 1/3 y, must be equal to 1/2 times 12. So that product is equal to that product. So 1/2 times 12. I end up with 1/3 y is equal to 1/2 times 12 is 6. And you can see that if I use my multiplication property right here and multiply both sides by 3, then I'll end up with 3 times 1/3, which is 1, times y, which is y, equal to 18. So this is a pretty easy problem to solve once I just use that means extremes property to get this little equation out. Once I have this equation, I have 1/3 y is equal to 6. I multiply both sides by 3 to just get y. You could, if you want, divide both sides by 1/3. That works just as well. 1/3 y divided by 1/3 is y. 6 divided by 1/3 is the same as 6 times its reciprocal, 3, which is 18. So either way I get the same result. Here's another problem. X over 10 is equal to 10 over 2. I'll multiply 10 times 2. I'll multiply x times 2, that will be 2x. And then I'll multiply 10 times 10, and that will be 100. Divide both sides by 2, and I get x is equal to 50. So they seem to get easier as we go. Simply apply that means extremes property. I multiply down this diagonal, multiply up that diagonal. I get an equation that's equivalent to this, and that gives me the simple equation to solve. I divide both sides by 2, and I end up with x is equal to 50. Here's our next one. 0.5x equals 1.4 divided by 0.7. So let's multiply x times 1.4. So I have 1.4x is equal to 0.5 times 0.7. Well, that will be 0.35 when I multiply those two together. 0.35. So now let's divide both sides by 1.4. So I end up with x is equal to 0.35 divided by 1.4. When I do that division, 0.35 over 1.4 on a calculator, I get 0.25. So if I would have kept fractions in this, I see that I have 1.4 divided by 0.7. I could have done that division right to begin with and just gotten 2, and then multiplied 0.5 times 2, and I would have ended up with 1. What's wrong with that? Oh no, this would be 2 over that. So x times 2, and that would be 0.5. Either way, I would end up with 1/4 or 0.25. So x equals 0.25 is the result of taking this proportion, applying the means extremes property, getting an equation, and solving that equation for x.